How are you?
The speaker? Yeah, so now our stuff doesn't work. Fancy, isn't it? Yeah. But then you need to take back control the same way. To get it back. Otherwise, we're going to get stuck on. Shall I ask for a note? So, give me some third person. Good morning. Good morning. Before we get started, we'll be looking for a note taker. If you're happy to volunteer, please give us a wave. Yes. Oh, would you love a volunteer? Thank you, Eric. Fantastic. I've got it open now. Yeah, so we can. Shall I run us through the opener? Or would you like to?
Good morning, everyone. This is MASQUE. We already have a note taker. Thank you to Eric for volunteering. I'm here. Wait, is this on? Yeah, this is on. Okay. Can you hear me now? Yes. Oh, you have to turn on the mic. So this is MASQUE. We already have a note taker. Thanks to Eric for volunteering. You should be familiar by now with how to run the Meet Echo tool. Just a reminder, please log in so your attendance here is registered.
Can you keep the mic close to your mouth? Yeah.
Still not loud enough.
Acoustics in this room are terrible. You'll have to be pretty forceful, even at this mic.
Okay, got it. This is the note well. We start every meeting with a note well. Please read it. This is more note well. Okay, quick update on what happened since the last meeting in Bangkok. We started a working group last call for 2 drafts. The proxying, the UDP, connect UDP bind, and for connect Ethernet. And we will have some updates for both of these drafts later on our agenda. We currently have 2 active working group documents, QUIC proxying and the DNS configuration draft. And we have 2 new drafts. One of them we already discussed briefly in Bangkok last time. And then we have 1 new document that deals with ECN and DCSP in Connect UDP. And we will discuss that later as well. Here's our agenda. We will first go over the working group documents, and then we will talk about the other 2 documents. Any agenda bashing?
For those folks that have to be aware of such things, there's been an IPR disclosure, which you can read online For those folks that are forbidden from looking at such things, congratulations, and continue to ignore it. So, sorry,
never mind.
Go ahead, David. Yeah. Then I think we've got Eric to take us away with QUIC aware proxying.
Wait, Gary's in the queue.
Oh, sorry, Gary, did you want to speak?
No.
Yeah, we'll set that up for you. I'll change the slides.
Hi, I'm Eric Rosenberg. I'm going to be giving an update on the QUIC aware proxying draft. So a quick recap on what QUIC aware proxying is. Essentially, if a client is trying to talk to a target over QUIC through a Connect UDP proxy, the client can share information about that QUIC connection, such as the connection IDs, to open the door to certain optimizations. There's a few updates since the last revision of the draft. Why don't we jump into each of them? So the first update is on, there was an issue filed about server preferred address, specifically if the target server advertises a preferred address, should we have any special text for this? We've added some text that says we largely aren't doing anything special here. The client is recommended to create a new a new Connect UDP request, and the proxies are now suggested to respond with the proxy status header with the next hop parameter, so the client can know which target IP it's actually talking to. All right, the next issue that was filed was about the new scramble transform that was introduced a few revisions ago. The idea here is that if an attacker modifies the part of the packet that's used for the IV, that's input to scramble, to be the same content every single time, it can look at the output packet and see that that portion of the packet is the same every single time on the other side of the proxy. And this allows for linkability of traffic on the client to proxy network path and on the proxy to target network path. We already have a lot of examples of active attacks against Connect UDP with and without the forwarded mode, but we added some additional text to call this out as a specific example. All right, the next issue, Lucas graciously kept us honest about our structured field values hygiene. So we updated some consistency issues between some terminology and when we use tokens and strings. So it's good to get that in. And then there's a couple remaining issues. The first one is about using the term ECB. There's some concerns around ECB being like discouraged in general as being vulnerable. We're using ECB in the scramble transform just for encrypting the part of the packet that's used as the IV. And then we use ASCTR for the rest of the packet. This looks, I think, very similar to what is mentioned in the QUIC header protection. We're using almost the same kind of terminology and pseudocode. So I don't think that this is an issue, but I'm interested in hearing, do folks think this is a problem? Do we need to change the language here, or can we leave things as is?
All right, I think people get pretty precious about the use of these terms. This is not something that we need to concern ourselves with, especially. We do need to ensure that the thing that we're doing is honest and has been reviewed at a level that we think is appropriate. But this is in the details of the implementation of what is effectively a crypto system. And if people don't understand that ECB when used in combination in this particular way, has this certain set of properties, then it's the usual thing where people get uptight about, for instance, the use of SHA-1 in HMAC, which still hasn't really been broken, for instance. And so there's a bunch of things where people fixate on, oh, you can't use that technology. And I think those are very simplistic takes on these things, and we don't need to worry about that too much. You could say CTR in this context as well, and it's exactly the same thing. However, I think it's much more honest to be direct about exactly what it is that we're doing, and CTR isn't a great fit, and we explicitly had this discussion in QUIC as well.
David Skenazy, agree with everything MT said. Simplest thing is add a sentence that says this construction mirrors the one from RFC 9001 section blah, and that way people will take their questions and go over there. This is fine.
Awesome, thanks.
Mike Bishop, I also think this is fine from a technical perspective. I wouldn't be surprised if during ISG review there's a question, so have an answer ready. That's it.
Thanks.
Tommy Polyapple. David, just to your point, the text does currently reference that exact section in RFC 9001, so I believe it is close this issue.
Yeah.
Awesome. All right. So the next, there you go. The next issue was another active attack that was shared that we have since added to the security considerations. The idea here is that an attacker can embed a signal by setting and clearing the ECN bits on one of the sides of the proxy, and then that signal is visible on the other side of the proxy. So no modification to the QUIC packet at all, just modifying the ECN bits. We added this since the last revision as just another example of an active attack. All right, and then we did have a chance to do some interop testing at the hackathon. We have 3 distinct implementations that we're all able to interop with one another with the scrambled transform. So really excited about that. If you have an implementation and want to do interop, please make yourself known, and we'd love to do that. And then I think we're going to take the feedback from this session and incorporate that into the existing draft and probably cut a new revision very soon, which we should be close to last call on.
I assume Mike's out of the queue. Martin Duke, Google. On the ECN thing, the text is fine, I suppose, but just say that like the network can modify those bits, so it's a pretty crummy channel to try to use to exfiltrate anything, since any router in the path could mangle a signal. Thanks.
Thank you. All right.
Okay.
At the
Thank you,
last
Eric.
hour, well, Tommy jumped in.
Tommy Polyapple. I just wanted to mention a bit more on the interop bits. So yeah, we did good interop there. That was useful. And as expected, there were definitely things that we learned from that experience that have already led to improvements on the working copy of the document. I don't think there was anything incorrect in there, but there were definitely things that multiple of the implementers, including myself, stumbled on. It was like, wait, what order do I do this thing in? And it was technically in there, but it was not as clear as it could be. So just an encouragement and a reminder that like doing the interop and implementation really helps make the text more clear, even when you wrote the text in the first place. So yeah, if there are other implementations, please let us know and we can test with you too. Otherwise, yeah, we're going to try to cut a new version of the document this week or next, and it should be good.
Okay, great. Thank you, Eric. And I think we've got Abby up next. to use the
Sure. All right. Good morning, everyone. My name is Abby, and I will be presenting MASQUE ConnectUDP bind today. So, quick overview. ConnectUDP with binding support lets you connect to multiple targets with just one ConnectUDP request. As you can see, the request has the ConnectUDP bind header, and the response provides the public address, the proxy public address to the client. And you'll see there's something that changed here, which is instead of the asterisk, we have the encoding. I'll talk about it a little later. Yeah, so we have the concept of opening and closing contexts. We use compression assign. When we set the IP version to 4 or 6, we're compressing that specific IP and port tuple. And if we set the version 0, we are willing to listen from any destination. Yeah, so interop update. We were able to do interop. Thank you, Marius. We were working on this up until last night, and everything worked. And changes since last time. We made some small changes to the draft. Yeah, so Marius again pointed out that the asterisk needs to be to comply with the simple string expansion of RFC 6570. So instead of so we just person encoded in the draft. And open issues. We got some pretty good feedback on the last call, which I appreciate. First one. So Ben Schwartz mentioned there must be a requirement that proxies must not allocate new compressed context to represent incoming packets that don't match an existing context. I think that that makes sense, and we're stating something kind of similar, which is when we don't have an open context, we do not want the proxy to be opening context. It should not be able to like open a compressed context at all. Yeah, so that's our proposed change in that PR. Okay, number 2, add MTU considerations. Yes, I think this one also makes sense. We added an operational consideration to say if the endpoint intends to use compression, they should do it as early as possible to not intervene with to not mess up the PMTU algorithm used in QUIC. Yeah, so this one actually is funny because in our interop we did kind of overlook an MTU thing, and it took us a while to figure out. So I think it's a good thing to add as an operational consideration. Yeah, so this one's the big one. So Ben had a very interesting proposal where instead of using the asterisk as the default target host and port, instead we were to specify one target that we definitely want to connect to, and then and we add the ConnectUDP bind header. So this is effectively a regular ConnectUDP request, but with a ConnectUDP bind header to say, oh, if ConnectUDP bind is not available, we would like to fall back to regular ConnectUDP. And yeah, so and then once this connection happens, you could add more destinations through the compression assign, or you can open an uncompressed context. Yeah, so it removes the need for first checking if bind is supported, getting the response, and then doing asking for ConnectUDP, regular ConnectUDP separately. And I did want to mention that there is if the client is not willing to do regular ConnectUDP, you can still mention the asterisk. That's the alternative. So So yeah, this, you might have seen this on a mailing list. It does facilitate WebRTC and ICE. So if, so ICE can be performed optimistically by sending datagrams before bind is confirmed. So if bind is not confirmed, you're still able to do, you're still able to check connectivity with a single target, and you're saving on latency here. Yeah, and so if bind is concerned, a new ICE target is generated using the proxy public address header that we mentioned before, and yeah, and the peer can directly migrate its connection, its existing relay connection to a direct connection, direct host connection, if they like. So yeah, this is the proposed change in this PR, thanks to Ben Schwartz's recommendation. Yeah, if people have any feedback on this, please let us know. So yeah, and then Martin filed an issue on our GitHub to say compression assign is wasteful and error prone. So currently, the way we confirm that compression assign is completed is the other endpoint needs to reply with the same compression assign. So it echoes it back to verify that it's received and processed the compression assign capsule request. And Martin suggested that we should have a separate capsule called compression acknowledgement with just the context ID. I'm not sure if how much this is like worth it. If people feel strongly about this, I do want to hear your comments on this, because I think the compression assign return is okay. David, go ahead.
David Skenazy is co-author of the draft. Like, this is a cosmetic change at this point. It doesn't make any difference. If we had discussed this months ago, we would have said, why now? But now we've implemented it, we've done interop. I'd rather not make cosmetic changes unless we have a demonstration that it makes a real improvement.
Thank you, David.
With no hats. So the reason I opened this issue is that every time you echo something, you need to check the values in there, right? So I need some extra logic for like, oh, what if I receive an echo with the right context ID but a different IP version or a different IP address? Now, like, why would you do that? Well, I don't know, but people do weird things in their implementations, and I'd rather not have to check for these.
Well, sorry. Well, we do drop or ignore the capsules if they're not valid, and I think.
Yeah, I don't want to have to check if it's valid.
Well, I don't think that's okay. David, did you want to go back on? Okay. All right.
Right. Marius Kleider. So the logic when receiving a compression assign capsule, you have to check anyways if it's like an acknowledgement or a proper assignment from the other peer. So you have to have the logic anyways to decide it. If it can be an explicit acknowledgement capsule type, I think that would be great, but it's also not a hill I'm going to die on. So yeah, I think I would be in favor of that, but yeah, that's it.
Yeah, thanks, Marius. Tommy, do you have any?
Tommy Polly Apple. I don't have a strong opinion here, but just kind of looking at other capsule designs, like what we have in the QUIC Aware for negotiating like the CIDs. That is a case where, yes, we do have an explicit ACK capsule, but it does include the information that you're ACKing. It's also kind of, it can add other things to it.
Right.
But I see it potentially being okay to include the information like, yes, you have to validate it, but it also means that when you send that ACK or reflect the assigned capsule back, it means like you didn't just have like, oh, here's a context ID and I actually did the mapping wrong. It means like, I am agreeing that context ID means these things. Is it a little bit verbose? Sure, but at least it's very clear that that what are you acknowledging? It's not just like, oh, you included a 0 in there because you had some error and it didn't actually mean what you thought it did. So I think it's okay to leave it as it is. Maybe I would have called it ACK, but whatever.
Okay, so I see there's not particularly strong opinions on this. And yeah, that's where we lean as well. I don't think the bit of difference matters as much. Martin, go ahead, please.
Yeah, I'm with Martin on this one. I think we've done this in a number of places where we have redundant information that needs to be checked, and it's just annoying to have to implement that, and it's wasteful. I mean, an extra the change at this point is annoying. I know for those people who've implemented this, but we have a pretty clear way of managing transitions between different versions. I think those people understood the risk they were taking when they implemented and deployed these things. So I generally tend to fall on the side of let's make sure that we do the minimal things so that there's no risk of these sorts of silly errors. I know that I sort of recognize Tommy's argument that it's good to have confirmation that the other side agrees on exactly what the parameters were, but that's not essential. It is most useful when there's extra to add, as Tommy points out. When it is a negotiation, I send you some set of parameters and you send me some set of parameters. That's a useful thing to have. But in this case, it's really, I'd like to set up this context. Okay, thumbs up. And if there's no need to communicate some information, I generally sort of say that you don't communicate the information. And so we should stick with that general philosophy unless there's a good reason to do it. And I think in this case, there's none.
David Skenazy, I'd say the Martins have convinced me. At this point, like the working group last call is pretty much over, and what we had decided to do after working group's last call is renumber the capsules to low 1-byte ones. So we're going to have one last compatibility breaking change. Fine. I'm okay with this. I do agree it's slightly better. And since we have to make a change anyway, I'm okay with doing this. Can you live with that?
Yeah, I'm okay with that. But
all right, let's just do it then.
I did want to, do we need an acknowledgement for closing? Is that something we would like to do as well? Or do we just...
I don't think, do we echo the closed capsules now? I don't think we do.
Yeah, no, we don't.
No, so we don't need it.
Yeah. Okay.
Because you stop using the context the second you either send or receive
exactly.
Close, so you don't need an acknowledgement. Whereas when you're setting it up, you need to know the other side heard it.
Yeah. Okay. I think that's about it. If there's any comments, please, Marius.
Yeah, I thought a bit more about the results from our interop, and I think there's a few minor things. The proxy public address header, I think, is defined as a structured field list, but it's not clear what the items are, whether there's tokens or strings. At least we ran into the problem yesterday. I was assuming it's strings, you were sending tokens. Mm-hmm. I think it says it's tuples, which isn't really that clear, but that's just a minor thing.
Go ahead, David.
Just to reply quickly, it can't be tokens since they're IP addresses and have things like colons in them, but you're totally right. Let's make that explicitly clear. File an issue and we'll write a PR in the next week or so.
Yeah. We'll definitely add that issue there. I think that's worth stating, and that's why interop is important.
Yeah. Another minor thing we ran into yesterday was that the proxy was binding to, for example, an IPv6 address, and then the client was sending datagrams with IP version 4, for example. That, of course, doesn't work. So maybe it would be great to add a recommendation saying that the MASQUE client should check the addresses that the proxy bound to see if it actually can send those datagrams. Otherwise, you're going to be lost in the void, and that might cause confusion. So yeah, that's just a minor recommendation. And regarding the MTU thing, we also run into that one. Like when you use, especially uncompressed context, you have a smaller effective MTU. The MASQUE client is likely aware of that. Like it knows that it's going to be proxied through the MASQUE proxy. But the other peer that is sending data to the MASQUE proxy might not be aware of that. So maybe it would be good if the MASQUE proxy would kind of recognize that if it gets datagrams that are too big and might then be dropped on its way to the MASQUE client, that it then starts a compression context already to just reduce the risk of those datagrams being dropped on the way to the MASQUE client as an optimization to make sure that they're delivered more with a higher probability.
Yeah, I think that's also reasonable. Yeah, I think these are very good findings from the implementation. Yeah, go ahead.
Hey, Lucas Pardew, Cloudflare. Maris reminded me that we over on the QUIC Aware forwarding call, there was an issue about like structured fields and lists and encodings and tokens and strings and stuff. So it seems like we maybe hit a similar issue. I would suggest going and looking at the text me and Tommy landed on in terms of stating what is the list a preference order or not, and these like quite basic things that we take for granted that like very easy just to put in words. I'm happy to review the PR to ensure some consistency. Thanks.
Thank you. All right. If there's nobody else, I think that's about it. Go ahead, please.
Jonathan Lennox, this is sort of a more broad question, but I brought it up in the chat and somebody asked me if I wanted to bring it. Given that the use case for Connect UDP bind is WebRTC, has anybody thought about how one specifies such a thing in a Pure Connections ICE servers parameter? Because the template URI is just HTTPS. It doesn't say it's mask or bind. So.
Go ahead, David.
David Skenazy, to answer that first. From the perspective of the rest of the network, MASQUE server is the same thing as a NAT. You're just getting UDP packets from another address. So I don't think we need to kind of tell, like all it needs to know is what the address and port are. It doesn't need to know that MASQUE is involved.
No, the point is that the browser is connecting to the MASQUE server to run a bind, right? So you need to know, I should get, the browser API needs to know I should connect to the MASQUE server so that I can get incoming UDP traffic, right?
But that's part of the browser proxy settings. Yeah, it's not part of ICE.
Oh, okay. So this would be browser proxy settings, not ICE. Okay. But something still needs to know to do a bind. But I guess that would be something in the browser internally. Okay, I guess that makes sense.
One way to think about it is that you use this draft when your proxy settings tell you to use Connect UDP, and you're about to open a non-connected. You bind to a socket. That's when you go, oh, I need this extension. And then I got up to say, just to ask the chairs, in response to Lucas's point, once we get through the next round of PRs, can you ask for an early review from the HTTP directorate? Because that's exactly the kind of thing where I'm sure we can get Lucas to review, but having an extra pair of eyes will be helpful.
Yep, we can do that.
Perfect. Thank you. I see Ben Schwartz.
Hi, Ben Schwartz, Meta. Also following up on Jonathan's comment, I just wanted to say, I think that the right way to model this is probably for the browser to treat the proxy as a virtual interface, which means that the bound ICE candidates that it creates are host candidates. And I wrote a draft arguing this point 11 years ago. So I don't know, we can talk about that maybe in a different working group.
Thanks, Ben. That's it. Thank you.
Okay, thank you, Abby. Next up, we have Alejandro talk about Ethernet.
Sure. Don't have that many slides, but. Hi, I'm Alejandro Cedeño, back for more Connect Ethernet. So we've made a few changes since the last meeting. Yeah, we're referencing QUIC's MTU probing. We've cleaned up some of the example URIs. We've got some recommendations to use higher level protocols and use this only when you actually need layer 2, just as a recommendation, and a bunch of editorial changes. We have a few other changes coming in that I didn't want to make during working group last call, but we're in working group last call. And what besides that? I would still love more interop. Those are the things I had.
Okay, is anybody working on interop at the moment and wants to come to the mic to talk about it? Okay, nothing yet. Well, thank you, Andrew. So we've finished.
Okay.
So, Gary Fairhurst, not the AD for this group, but having kind of a pair of eyes on this document a number of times, and very appreciative of the changes you're making. This is definitely improving. It's good. I would love to see the interop bit. That would be cool.
Me too.
I have a couple of things that read oddly when I read through the document in various places. I mean, one of them is like, you must limit the buffering. That's a good must. What does it mean? And if you exceed the must, then you must drop. Yeah, that's cool. But I think we need to be a little bit more precise. If when we say must, we have to have something that is actually defined.
Well, that's fair.
Then there are 3 things in total. The second thing is the title. Is this Ethernet? Are they Ethernet frames that we're tunneling?
Yes.
Yeah, well, that's what the abstract says, and that would be nice if it was somehow in the title, because I fear that Ethernet proxying would raise a lot of interesting review comments if you send that out more generally, just saying this is the whole of Ethernet we're proxying, because there's lots of things in Ethernet, right? And all we're doing is extending an interface or tunneling frames across something. So I don't know how we make that easier. But then the bigger thing is that there's a whole section of stuff that you say isn't really there. And that includes how to deal with broadcast multicast. And I don't quite understand how this works without broadcast multicast, because that means I can't do neighbor discovery, RA, etc. So it isn't. Can we say something about that? You just have to send multicast frames or something? I mean, it seems like there's a big missing thing there, which makes this absolutely useless to me.
So for what it's worth, my implementation does carry broadcast and multicast frames, as does, a patch cable.
Exactly.
So we're not saying that this protocol needs to do anything specific with those. That needs to be handled by the stuff that's dealing with all of the interfacing with the actual Ethernet physical segments on the other end.
Yeah.
But we can carry the frame across just fine. And I think that's what we're saying already.
I think that's not what you're saying, but I think that's what you intend to say.
I believe that second part for sure.
Okay. Right. Okay. So I'm kind of pushing back a little bit. rather vaguely. I can do it very specifically if you like in GitHub, but I think there are things here that need to be tidied up before it gets wider eyes, because for this group, you think you can do it. But for other people, they're going to go, well, what the heck is this? And what are the boundaries of this? And I don't think this is a big thing. It's that maybe that section 7 that needs to be a little bit more precise and descriptive, and maybe some standards language in there.
Yeah, sounds good.
Lifecycle at Mozilla. Along similar lines. I made the point earlier, I think, at adoption, when the adoption question was raised, whether there's Ethernet and whether all the Ethernet things in it. And I think there's some uncertainties here. I do believe you have probably what you need to carry the frames, but that might not be all. The other thing that concerns me is the lack of interop, which, i.e. the lack of interest from other parties to implement this. And one way forward here that I want to pitch to the working group that's going to make you unhappy is whether we should go experimental with this. Because in the QUIC space, typically we have had very strong interop before we went proposed standard. And this is different enough that I think that should be an option for discussion.
David Skenazy. I'm getting a lot of deja vu from the conversations we were having around Connect IP a few years back. And in particular, when the document went out for wider review, and our beloved Interior reviewer had some thoughts about whether it was a link or what is a host and a router. And that was a long conversation. At the end of the day, none of that conversation led to changes in the protocol, but I think it led to some clarifications in the document. And so for the example of multicast here, was the exact same thing of what we did for multicast in Connect IP, the answer being, this is a way that you send your frames, their packets from one end to the other, and then something needs to do all those. For IP, it was the host responsibilities of duplicating the multicast. Here it's a bridge, but similarly, it's not in this protocol, it's sitting right next to it, most likely in the kernel of your OS. So I think I understood it the way you intended it. So maybe Gori, if you can file specific issues or because I think we could definitely improve it. On the topic of interop, I thought there was interop between you and Ericsson back in the day.
There was the smallest bit of interop.
Okay.
An ARP request was sent, an ARP reply was received. And that is as far as we got, because reasons. Like,
I mean,
that's as far as had been implemented for this test. So frames were carried.
I mean, for Connect IP, I think we did the same thing with a ping. So it's
Sure.
Maybe let's try to get that one again. I think if we definitely have one implementation for sure. If we get two to interoperate, I think that clears the bar for standards track by miles for most of the IETF. And I would like to keep the standards track if we can.
Yes. No, to be clear, we had that much interop. I want more interop for sure, but we've had more than 0, which does make me happy.
Yeah, MASQUE live in Ericsson. Yeah, we did this interop and we stopped there because we felt it was easy to implement. It worked, and like we didn't feel we need to do much more, but we could do a bit more. And like having one more implementation would definitely be super nice. So, yeah. What I actually wanted to say is like so far, Gori, your comments sounded more editorial to me, and I would actually see some GitHub PRs for that. I think that's easy to apply. And talking about Connect IP, I mean, this draft basically took the text from Connect IP and just stripped it down to the minimum we needed for this one. And then we also tried to kind of not add too much like to experimental stuff or whatever, right? We really kept it to the minimum to make it actually not experimental, to really kind of, make the functionality that you take a packet, put it in on one side and get it out on the other side happening, right? And there's nothing about any kind of special cases, because in that sense, it's really just like a link or whatever you do on your Ethernet router, you can also consider here, but it's on a lower layer. You don't have to like talk through all of these cases in the draft. So I think what we have in this draft is minimal enough that it's like very straightforward, easy to implement. We can work on the editorial part. If we need in future any kind of special case handling, we can add in, we can start a new draft, but it's not in here, and I'm not sure we need it at this point, because this is not like, we don't have these special use cases for it.
Gori Fairhurst back again just because we're mentioning it. But I think section 7 is basically benign rather than helpful. And so it needs to be helpful. So this is the place where I see the place you need to do it. And we've just talked it through here. I mean, it's effectively a long cable that then goes through a proxy and carries on until it reaches a device at the other end, which knows what to do with Ethernet. And we have to explain that properly in the document, but we can't say we're connected to broadcast domains and then we say we don't know what to do with broadcast. I mean, that was there are these inconsistencies, which probably means that nobody's read this with a view to implementing it and going, well, what's this about? Because I think we know how to do this, it's just haven't written down in 7. I mean, I can give you a long list of things that we might be missing, and I guess one of the ARICs could from the int area as well. Or you can copy it from another document that exists. I mean, other people have done this in the IETF. It just has to be in that section. And it's not going to affect the mask, but it's going to affect the people who are doing the IP layer stuff to know what they're connecting to, what it is.
The IP layer?
Right, if you read section 7 critically, it doesn't make any sense. Right, so because it says you don't know, you're not responsible for bridging, but then you don't say, well, actually, you're connecting 2 bridges together, which is kind of what you're doing. So you need to figure out what section 7's about.
No, but this is not, is this an AD comment?
This is not an AD comment.
Yeah, right.
I am an AD. I'm not your AD, so it's not an AD comment. It's a comment for a group of people who've looked at these sort of documents, and this is going to be something that other people in the IETF will discuss. So let's do it in the working group.
Sure. Yeah. The point is, I think for us 3 at least, the text is clear. For you, it's not clear. So you just have to tell us exactly what is not clear for you, and then we work on it.
List of issues.
And I just quickly wanted to comment. So even this is, even if you think this using Ethernet here is overclaiming, I think I wouldn't want to rename it because it really fits in the terminology we're using for Connect IP and so on. So then, yeah, if we can add some explanation at the beginning, making this more clear, maybe that's a way to go.
Lars Eggert, Mozilla. So as a constructive way forward, in case you haven't, RFC 4448 is Ethernet over pseudowires. And there's a lot of things in that document that I don't think your document touches. And I think that text was put there for a reason. And the pseudowire working group was basically in the same kind of shape, right? They did encapsulations for anything under the sun at the time over pseudowires.
Yeah.
And that's just one example, right? There's other int area working groups around the 2000 to 2010 timeframe that tunneled. Tunneling was the hot shit back then. Apologies for the words. But so the pseudowire people actually did the work of trying to understand what does it mean to carry Ethernet over a tunnel. And it has a whole bunch of things about how you integrate a Ethernet pseudowire into an Ethernet network, an L2 network. And maybe take a look and see if there's anything that you can take for this document to address some of Gore's concerns, because I think they're valid. Thank you.
Yes, I did read those earlier. I might give them a second or nth read. But it was definitely enlightening the first time I went through them.
If you read it and you didn't find anything in there, I think that might be useful to explain in the document, saying like, there's been past attempts of tunneling Ethernet in different contexts. One is this one. We didn't need all of these things that they specified back then here because A, B, and C. That would be super helpful.
Okay.
I remember one more thing. Gori also said the int people might have the same consensus. We did request an int area or directory review. Did we ever get it?
Yeah, we got it back fairly recently.
Okay, so I didn't see that one yet. Yeah. What did it say?
I think it was ready with issues. Oh, I'm misremembering.
I forget which ones we've gotten
it came in really late, but I'm glad we got it. So
yeah. Okay, so just try and capture this. Like, I think there's some concerns. It would be good to see those concerns become specific feedback on the mailing list or on GitHub. I think some meaningful interop would really convince a lot of people that this is this is ready to go. And I think that would be the most valuable thing we could do in the short term. We've already asked IEEE for feedback on this a couple of times, and we've heard very little back from them. They might see it when it exits the working group, but I don't think we can do anything more there to get meaningful feedback. Is that fair?
Yeah.
Yeah. Great. Okay. Thank you so much. And I think we've got Yaroslav up next.
Hello, everybody. This is DNS configuration for proxying IP in HTTP aka Connect IP. As a recap, this is not a new way to transport DNS. We have enough of them. This is about signaling DNS resolver configuration over capsules to be on par with traditional IP VPNs. So we had made few changes in the latest revision. Based on rough consensus that we had at the last meeting, we have removed DNS request capsules. So now DNS assigns are only unsolicited. So apparently there is no reason to do DNS request. You either do DNS assign or you don't. Which also allowed us to actually simplify a bunch of things. For example, remove request ID from DNS configuration. Well, no, there is no more DNS request. And the DNS assigned capsule now carries a list of DNS configurations, so it now behaves similarly to other capsules in Connect IP. That is, it's overriding or superseding all the previous information. So if you received a DNS assigned capsule in one direction, that means that all the previous ones are invalidated. So this is what the capsule, so it's no longer plural, it's a singular capsule that we now have in the draft DSN assign looks like. It's a list of 0 or more DNS configurations. 0 configurations is potentially valid, and it could be used as a way to say that, hey, I no longer do DNS. So you could potentially revoke your previous DNS configurations by signaling DNS assign with empty list, which means you no longer do DNS around here. DNS configuration itself is exactly as it was before, except we no longer have a request identifier, and name server structure is the same as it was before. One of the reasons why you could have more than one DNS configuration is you could potentially have different name servers serving different internal domains. So you could have this somewhat sophisticated split DNS configurations if that's your thing. Now, there is one thing that came up. It's not necessarily strictly related to DNS, which is Pref64. So if you, like me until recently, don't know anything about Pref64, this is actually pretty straightforward mechanism for IPv6 only networks. So in case of Connect IP, that means if you have IPv6 only route assigned, so you don't bother giving IPv4 addresses, you only give IPv6 addresses. So that is you, and then you have an endpoint that needs to communicate over IPv4. So user types in IPv4 address in the browser, or you have some weird application that doesn't do DNS lookups but speaks IPv4 directly, and you want to send that through that proxy that will eventually perform NAT64. So Pref64 is a mechanism to signal an IPv6 prefix that could be used to, well, prefix that IPv4 address. So then your proxy would be able to do NAT64 and translate it back to intended IPv4 address. So again, it's nothing really to do with DNS, but it's pretty straightforward mechanism. It's just a single capsule. So now the question that we have, should we slightly expand scope of this draft and have a single draft with 2 simple capsules in it instead of just 1, or should we create a new micro draft just to define a new Pref64 capsule? Now, co-author's preference is just to expand this draft and get the whole thing sooner, but I think we're open also to launch that as a separate initiative if that's the consensus. So anybody have opinion on Pref 64, and also anybody have an opinion on our latest changes in DNS, because I believe that other than Pref 64, we're pretty much complete and ready for working group last call.
David Skenazy. Just to add a little bit of context on this, you're right that Pref 64 is something that you use with NAT64, so isn't inherently related to DNS. The reason this landed on our lawn is Magnus over here, is that up until this Pref 64 was invented, this technique for that was RFC 7050, which relied on DNS in order to get the prefix. And that worked for many years. Our friendly folks over in IPv6 land realized that having a direct way to communicate it worked much better. And that's how they ended up here, because we're doing DNS, the traditional way is DNS 6.4, this is better. So from my personal perspective, this would be a very simple addition, and I would recommend adding it. Like, it's, you know, a draft for small things is a lot of wasted effort, whereas I think if you don't need to squint very hard to see that it makes sense for these things to be related.
Somebody else in the queue? Ted?
Ted Hardy. Thanks very much. In reading the handling of DNS assign in the draft, it's very clear that the new DNS assign capsule supersedes the previous configuration capsule, and I appreciate that clarity. However, when you spoke there about invalidation, it kind of raised a concern for me that maybe you want to insert in the draft one way or another. When you receive a DNS capsule with new information, my presumption is that you do not invalidate any DNS cached entries that were associated with the previous one. Somebody reading the draft or listening to this might come to the opposite conclusion. So I suggest you actually make explicit in the draft one way or the other what the intent is. And if you're going to ask me, I would say do not invalidate previous entries would be the correct behavior. And that's because it's going to be complicated to track if you have to do that. But I think it might be valuable to make it explicit in the draft one way or the other.
Sorry, Ted, just to make sure I fully understand. You're suggesting that the language should be along the lines of should not invalidate?
Right, that it supersedes the configuration for future queries, but does not invalidate cached entries which are still fresh according to the DNS rules. Make sense?
Yeah, makes sense. Perfect.
Okay,
Thank you.
Jonathan, like just on the prefix 6.4, I don't care what you do, but if you do add it to this draft, make sure the title and abstract don't just say DNS so people can actually find it.
Thank you.
How's the interop situation looking for DNS?
Yaroslav has an implementation. I have an IOU one. What do you call it? A concept of an implementation. I'm really hoping to get that soon, but I don't have it yet. And we're thinking like, I don't want to hold things up, but I think it would be good to get that before working with last call. Yeah, but if anyone beats me to it, even better.
It's work in progress, and I guess if we extend it with Pref 64, we should also do Pref 64 while we're at it.
Okay, that sounds great.
Thank you.
Thank you, Lester. Okay, up next we have Magnus for ECN and DCSP support.
We have a working clicker in this room.
Okay, I'm Magnus Westerlund. I'm going to talk about ECN and DCP for Connect UDP.
So there were 2 independent proposals for ECN before this meeting, one by Martin Seaman and another from us at Ericsson, me, Mirja, and Marcus. They just forget to put their name on the draft. That's we're involved. But so the use case for this for using ECN is really to enable end-to-end ECN negotiation. So that's relevant for WebRTC, potentially for using ECN for improving the congestion control response, etc. There are congestion control algorithms, etc. You also have, in certain cases, the privacy relay tunnels use cases, where if you want to have ECN or L4S, for example, working through, you would need to have it working through these tunnels too. In 3GPP, there's this ATSS that could go to private networks, etc., as well as public internet. This is basically, and to enable ECN across that end-to-end would also be good. And we have one very particular case where the tunnel isn't maybe necessarily where you would expect it, at least not from 3GPP standpoint, because this is actually from between the application server towards the mobile network. So it's across internet. And so it's actually the mobile link here is not being tunneled at all. So we just need to ensure that we have end-to-end. And this is intended for XRM, which is a high likelihood of using L4S. One observation in general here is that when you start marking with that your traffic is ECT, could happen at any point in the flow lifetime. So especially like there's quite, for example, QUIC ECN spec, I think, recommends to not turn on ECN after the handshake completed. Things like that. It's the same is true, I think, for RTP to ensure that you have passed packets before you enable it. So then we have the diffcert code point usage. Here there is a bit more, depending on the use cases. It could be fairly likely that you just have a single DHCP per phi tuple of UDP flows. Cases where you might see multiple. One is WebRTC, which has defined a number of set of different traffic classifications within a single phi tuple, which is the aggregated WebRTC that combines the data traffic and media RTP traffic for several different potential media types, and therefore might be using multiple diff circle points. The same would happen if you would run any type of UDP-based tunnel aggregate across this tunnel. So tunnels over tunnels, you could end up in the same case. So that's the motivations. The drafts on the ECN side both had these kind of, let's map different ECN code points to different context IDs. So that you're basically saying, okay, what's the real underlying payload, but also the ECT with 0, ECT1, or if it's congestion experienced. In the Ericsson draft, there's also 1 byte DHCP proxying payload extension. So it puts in the whole full 6-bit diff code points plus the ECN bit, 2 ECN bits. And that just uses then one additional context that it say, hey, this is the combination followed by the rest of the payload. So I want to mark that this is independent of what happens on the tunnel connection, so let's say the HTTP transport connection. That might use ECN or it might not. That's a separate topic. It can be combined either way. The special case which is worth pointing out is where you have, if you're not running congestion controlled of the datagram traffic where you tunnel, you could have either mark down or just mark it as ECT and then mark up on the egress following RFC 6040 and 9601 to handle this. If you have congestion control, you would basically have to use the congestion controller and AQM to control and mark the end-to-end traffic according to what fits in the tunnel currently. Or if it's not ECN enabled, you would just drop the packets. If you have HTTP proxies in between the 2 ingress and egress, you would have to deal this each connection independently. So setup signaling. They're both capsules. Our realization after discussing this and seeing it's like we do need capsules, because if you're looking at the UDP listen draft, the proxying bound, that's establishment happens after the initial. So the context of these that you potentially need to bind the ECN code points to doesn't exist at the start of the establishment disconnect UDP request. So therefore, using HTTP headers do not work. So we're gonna need capsules. Request response, you could do this to also bind context IDs, but it might be not just sufficient to indicate that you're capable of dealing with the capsules. But I think this is for some more thought and deliberations around this, if you're gonna do both or just have capsules plus capability. One of the bigger things in this here, which actually I think needs the working group's feedback on, is dealing with this fact that we're now starting to have extension payloads that change to other UDP proxying payloads. So we have context ID 0, which is just the basic UDP payload. We do have the proxying bound UDP, which has the unregistered proxying payload, which contains address information plus the UDP payload. And now we have like, we're also adding a diffcert code point on top of this. We do get these kind of chains. And how are you dealing with this? Are you just saying, okay, in these cases where you have explicit payloads, are you just adding, okay, this CID is HTTP plus SID2 and SID6 is 0, so we have this what's described on the slide with the image. We get just these simple combinations and just have the chain of SIDs. If we take the version we're just putting on the ECN bits, we have 3 additional diffcert code or SID context IDs per underlying proxying payload that you want to represent. And so what happens with the registered for bind, etc., is that as soon as you register that, you need to register 3 additional context IDs for. So that would mean that you would end up with 4 per address that you register to represent ECT, or ECN plus the address. So we do get this combinatorial explosion here, especially if you would have one more layer. For example, if you would actually like to encode 1 or 2 diffcert code points on top of this, yeah, we could easily double or triple this. There's in the kind of offline discussions before this session or earlier this week, we have talked about one alternative to keep down this explosion would try to stick actually the context ID identification bytes in the payload. So that if you take this case, you would have like what the uppercase represents was today. There's already one in the HTTP datagram. Points to saying the connect UDP defined HTTP datagram payload starts with a context ID identifier. But in this case, if you're going to have the diffcert byte, would add 1 additional field that would then say, okay, this diffcert byte plus the context ID field. And of course, depending on how many of these you have slightly different properties as they are variants, but in most cases, if you have a description for the whole payload, you would just have 1 variant for them. So, yeah, so this is kind of an aspect here of saying, how are we dealing this? What are we comfortable going forward with in this regards to how we handle this kind of chaining? I don't know if anyone has some feedback on these kind of aspects of how do we want to deal with this? Mike?
Mike Bishop, not as AD. This issue seems independent of ECN. This is
Yes, it's a general, as we put in more extensions into the MASQUE space, so to say, we're gonna more and more run into this. So.
Yeah, and this is a generic issue with the way we did extensions in MASQUE, and ECN just happens to be the extension that ran into it. I kind of question whether it belongs in the ECN draft, but
yeah,
maybe it is something we need to fix.
Yeah. Yeah.
Hi, Ben Schwartz. So I think there's some philosophical questions here, but I think that my core technical comment is I don't think we can assign separate context IDs to the different ECN values because context IDs are variable length. So there is a chance that your different ECN values could have different header lengths and therefore different effective MTUs. And I can only imagine what strange things would happen if you tried to do path MTU discovery and then the MTU fluctuates depending on the ECN state. So
isn't that fairly easy to avoid by just thinking about what numbers you are? If you're to ensure that when you're assigning this, you're keeping them within the same number of bytes.
So that's okay. That's possible. I think that's I wouldn't call it fairly easy. Like we're now asking implementations to pierce the QUIC variant abstraction barrier when making context ID assignments. That seems like too deep to me. My philosophical point is I think we should be careful about wasting MTU, but I am suspicious of the value of this at the point when we're trying to save less than 1 byte of MTU on average. So that's sort of the threshold where I would say, wait a minute, is this actually worth it?
So it feels to me that it would be beneficial to design it in a way that would be extensible to TCP as well. Now, in traditional Connect, obviously there is no place to provide DSCP, but with templated TCP Connect that's using capsules, we potentially have now flexibility to add DSCP if we feel like it. It seems that it would be good to not necessarily encapsulate DSCP and ECN inside context, but have it as a separate field that would be portable then to TCP if we decide to do that instead of reinventing completely different encoding capsule mechanism for TCP.
So isn't TCP a bad example? To my understanding, TCP works, the normal connect request is back-to-back TCP sessions across the whole end-to-end, and therefore this doesn't apply because you run it just on each individual leg.
Correct, except templated Connect TCP that is now in HTTP working group is using capsules to encapsulate data, which means that you can...
But it's encapsulating data, not packets.
It's segments, and you could potentially have different DSCP markings and do different actions depending on those values.
Okay, well that's maybe...
Ben came up,
yeah.
So I think he has something to say.
Yeah, so just to be clear, the Connect TCP draft does not say that each capsule is a TCP segment. Each capsule is defined as some arbitrary contiguous subsequence of the TCP data byte stream. If you're defining new capsules, you can do all sorts of interesting things with them, but certainly the current specification sits entirely above the TCP abstraction and just deals in byte streams.
Okay, Thank you.
Okay, with no heads. One thing to keep in mind when designing the chaining of extensions is that ConnectUDP has the nice property that you can send datagrams optimistically. So you can send the connect request, and then you can immediately send datagrams for that request. And if the proxy says like, no, I'm not willing to proxy that request, these all get dropped. Sending things optimistically, though, requires both ends to agree on what the encoding is. So this is a complication in this design space.
Tommy Polly, Apple. Thank you for doing this. It's good to enumerate all the cases. Good we finally got around to it. When we're talking about the capsule composition design, it really reminds me of all the stuff we talked about very early on in the group. I feel like we really covered a lot of these options, and I think this was very much expected to be how it's going to be. I don't see that there's necessarily a bug in how the capsules and context works. This is just a case where we need to have it explain how it is. So I think it is appropriate for this extension to come up with how it composes. And it is to some degree up to each extension to say how it works. And I think this is a very good example of where it makes sense to do the chaining. I think the chaining is the right type of architecture as opposed to trying to have it have the combinatorial explosion for every way it could possibly compose. And this then can become an example for other extensions that really just have like a next context field. It's like IPv6 extension headers in that way. And then to Yaroslav's point, I think this would work fine in front of TCP. You could just chain it in front. I don't think that's normally what you would do, but I think it's more just an example for things that can chain on front. Those should work for TCP if they're applicable. I don't know if ECN really is, but I could imagine other things that are just other color and decoration on the capsules going through that can get tacked onto the front.
David Skenazy, Google. So thanks for doing this. I think, so first, I guess, to go in reverse order of what Tommy was saying, I don't think this goes particularly well with TCP, specifically because the data capsule for Connect TCP does not respect packet boundaries. And ECN and DSCP are per IP packet thing. So I don't think we should go down that path. It doesn't quite map well. Secondly, on the topic of accessibility, like what Tommy said, in the very early days of Connect UDP, we discussed this, and one of the things we considered doing was defining this, composability of extensions. And kind of the mindset that we decided on, which we've been continuing, I think, to this day in this working group, was to not try to define a unified theory of MASQUE and only build things as we're using them. And as we get forward, we've learned, oh, this works better than that. And I think that was the right call. If we had designed this composability at the time, I suspect we would have gotten it wrong because we didn't know what we were going to use it with. And I still think that we're kind of in this boat here. If we, right now we have 2 extensions, and my recommendation would be to have the ECN document say, okay, here's how I compose with the other one. And then once we have the third, maybe then we go, okay, now we have 3 examples of this thing, let's define a way. And that's fine. It might mean some duplication in documents like Connect UDP, Connect IP, Connect Ethernet all have a same section called context ID that duplicates the thing. The world doesn't end. And we keep improving it slightly with every document, which is funny. So I'd recommend doing that. And then my final point on this, kind of at a higher level on ECN, is I think we're going to have to find ways to negotiate which parts of the, when there are multiple quick connections involved, which are doing ECN or not, which you can kind of glance at from like ECT0, ECT1, but being more explicit, because then on decapsulation, it gets really tricky and things can go really sideways if you do ECN instead of a drop for a congestion controller that's not going to react to the signal. It really depends on the use case, because if you want to combine them with a next hop thing, that gives you the most extensibility, the most it conveys the most values, but it's also the least efficient over the wire. Whereas if, in the case of ECN, you just reserve 4 context IDs instead of 1, you've now wasted 0 bits to encode this information. You've just used part of your context ID space. And I think it really depends. And so for this draft, because the use cases are pretty high, you might have a use case where you have a generic tunnel that can do every DSCP value. But in practice, you probably only have 2 DSCP values or 3 for your given application that's running over this. So you don't need the whole space. So I think in general, the idea of registering and then putting that in the context ID is very attractive, because in general, you're not running a complete abstract thing on top of this. You're running a very specific application.
Yeah. Yeah, thank you for all the feedback. I think we're going to have to continue this discussion. And that's exactly what I want to do in this working group. So, and I have seen some interest in this. So my understanding, next steps here is that we will work with Martin, etc., and write some combined draft, etc., and continue this discussion. But and hopefully for future adaptation.
Yeah, I mean, I think we'd be happy to get a sense from the room now, if you'd like.
Yeah, please go ahead.
So we've got a poll up. If folks could just give us a general sense of how they're feeling about this.
Looks good.
Okay, it looks like we're stabilizing there. But for the note taker, that's currently 24 yes, 0 no, 5 no opinion. So I think that's a reasonably strong signal to adopt something in this space. And I guess we'll need a little bit of time to figure out what that shape is and the extensions combination issue.
Yeah.
Okay, great. Thank you, Magnus. Okay, very quickly for the very last item of business. So previously, David has presented the MASQUE proxy draft, which kind of details what MASQUE is. We've had a conversation with Mike, the AD, and David, and the proposed solution is that it's basically that it's not quite within our charter at present, but we could easily do a small recharter to bring it in scope, and that would allow us to work on that document within MASQUE. And then secondly, that as part of that recharter, we would remove the language around sort of accepting new extensions. We would just call out the existing working group documents that folks are working on, and the ECN draft, for example, and then yes, begin the process of sunsetting MASQUE as a working group. Do folks have thoughts they want to share at the mic on that as a way forward? Any concerns or any alternatives?
Yaroslav Rosamachov. So if we're no longer accepting new MASQUE extensions here. Do I understand it correctly that the intent that they will be going to HTTP working group? And do we expect HTTP working group to have cycles for that? They have 2 meetings each IETF and they're pretty busy.
Lars, I agree on them being busy. What new MASQUE extensions do you envision a group doing?
So a couple of things that I've been exploring, not yet ready for publication, is compression for Connect IP. For example, one thing that in my implementation consumes at least 5% of CPU time is computation of TCP/UDP checksums. When you're working with tunnel interfaces, would be great to have a way to signal that, hey, we don't want to do checksums here. If you have both checksum of loads on both sides, and some compression things could help with MTU pressure. That's immediate examples that jump out on me.
Thanks, that was helpful. So I guess maybe we should do a little, I don't know if we want to do this now or ever, but figuring out if people have other things that they have held back from bringing here. Because when you also said that, I saw a bunch of people nodding. So I guess there's some interest in the broader community to have some things. And it would be not great if we closed the working group in that or limited the scope too much. We might at least want to include concrete things that people have plans for and see if there's a consensus and add them to the recharter. I do agree generally that we want to hurt the cats a bit harder going forward.
Tommy Polly, speaking as HTTP BIS chair, since it was proposed that we're going to get all the work. I think in some cases, like we already see MASQUE-like things that have gone there. The templated connect TCP is there. It is very much in the spirit of this. It has capsules and everything like that. But it is not in MASQUE. I think that's appropriate. So work, I think, on the heart of capsules and things like that. Sure, that belongs in HTTP. But I think there's also MASQUE proxy related things that happen elsewhere. Like we have some of the proxy config stuff, which is referring to MASQUE and about MASQUE that is happening in int area. So I guess to Yaroslav's point, if there are things about, oh, connect IP tunneling and how do we do compression, I think it'd be good to figure out what is the right home for that. Like, is that almost like an int thing because it is dealing more with how do you deal with tunneled packets? And maybe that does have a home somewhere else that doesn't need to be MASQUE. I think it makes sense to have MASQUE be able to close and say, yes, we delivered our core documents, and then we should just have a direction that maybe sometimes you need a new working group or a new BOF, but that there are places where we say that, yes, maintenance of capsules and things goes into HTTP, but maybe some other generic proxying or tunneling work goes to something like int.
David Skenazy, I agree. I think it'll be good to scope this down and close this down, get a big banner that says mission accomplished. I think maybe scoping it down, compression is also the only thing that I can think of as something that seems down the pike. We just haven't deployed Connect IP in production for us yet, and I'm hoping that someone who deploys it will then say, yeah, we're getting all these MTU issues like they saw in the interop for Connect IP bind this week. And then that's how we'll know how to do the compression. I think we know, but we could imagine as we scope it down and list compression explicitly as what we want to do before we close.
Mia Kulevin, I wanted to say the same. Maybe we can wait until we have. I have this on my to-do list to write a compression draft, but I'm sorry I didn't do it for this meeting. I can maybe promise it for next meeting, so maybe we can wait for that before we scope it down. Also, I would like to see the text that you're actually proposing for the charter rather than talking about it in the void.
Hi, Ben Schwartz. I think there's a divide between some things like wrap up that are really generic capsule protocol functionality, which can reasonably go to HTTP BIS, and really transport oriented functionality that happens to be expressed using the capsule protocol in combination with the MASQUE, the MASQUE sub protocols. I think that that kind of work, like if there are flags that we end up wanting to define in as a follow-on to connect TCP, for example, I think that kind of work could potentially go to TSB working group or int area. As long as there isn't a ton of it, I think we could probably still close the MASQUE working group.
Okay, thank you all for that discussion. You'll certainly see some text, I think, on the mailing list, before we ask for anything more concrete. Oh, sorry, David.
Just before you wrap up, if I could take a quick minute. Last week, Eric Kinnear stepped down as chair of the MAC working group, so I wanted to thank Eric for his service the whole time. Thanks, it's been a pleasure.
Yeah, and I was about to come on to much the same, but thank you, David. And thank you, Eric, as also for taking notes for this session. Thank you to all our presenters, and thank you all for coming to MASQUE at 1:23. Yeah, I think it's a bit more